Good morning, everyone, and welcome to the Oxford Generative AI Summit. In a world that's so dominated by AI now and digital interactions, it's so nice to see everybody here in person. My name is Cassidy, and I'm the director of this year's summit. It's a tremendous honor to be organizing this event, which is bringing together such a diverse and distinguished group of multi-stakeholder leaders and experts. I hope that you all have an incredible, enriching, and generative 2 days ahead. Have the best time in this historic and beautiful city, thinking and discussing AI in this beautiful state-of-the-art venue. Hope that your weekend is filled with enlightening, thought-provoking discussions, new friendships and opportunities, exploring Oxford for those that are traveling overseas, and really insightful conversations and reflections on the profound implications, exciting use cases, and future of generative AI in society. I owe a significant gratitude to a number of people and organizations that have helped to turn this event into reality. Thank you to our amazing sponsors, our lead sponsor, TruePic, our silver sponsors, BCW, Decipher, powered by Limbic, and Northell, our bronze sponsor, Razorfish, and associate sponsor, Adarga. Their contributions to this summit have been invaluable. Let's give a huge round of applause to our sponsors. The summit would also certainly not be possible without our spectacular executive team, advisory board, our volunteer team, staff at Jesus College, and everybody that will be helping to support us all throughout the weekend. They've worked and will be working tirelessly for this event. Another huge round of applause for everybody involved in making this possible. Certainly last but not least, would like to give a huge thank you and round of applause for all of you, to our speakers and attendees who are joining us for the summit this weekend. Another round of applause. And now, without further ado, I'd like to announce our first keynote speaker, Sir Nigel Shadbolt, a leading researcher in AI and one of the originators of the interdisciplinary field of web science. He's principal of Jesus College, Oxford, and a professor of computing science at the University of Oxford. He's a chairman of the Open Data Institute, which he co-founded with Sir Tim Berners-Lee. He was knighted in 2013 for services to science and engineering. Let's give it up for Sir Nigel Shadbolt.
My friend and colleague Tim Berners-Lee once said to me, everybody is somebody's tech help. So, everybody. Okay, so I'm going to kick off. I've got, I believe, about half an hour, 20 minutes plus questions to kind of set a bit of a scene. It's great to have you here. We're delighted to have you in this space. We're very proud of what we've constructed here in the Digital Hub. And it was always conceived as a space where we could share and use it as a platform to understand the disruptions that the digital age is kind of yielding up. And there is no more interesting example of that, I think, than AI at the moment. So I've been working in AI for, well, longer than I care to remember, decades, in fact. So it's been a very interesting journey, but I'm going to just précis my sense of what's happening in generative AI and why it is both an extraordinarily exciting time and one where we should tread with a little caution and be reflective about what's happening. I also do this from a number of contexts as head of college, but also as a professor in computer science, where I head up this human-centered computing group, but also my other passion around open data, the Open Data Institute in London, where we're always advocating for an open and trusted data ecosystem. I'll say something about why I think that's important in the course. So, roll back to the pandemic, deep in the pandemic, 2020, I was invited to give the Christmas lecture to the all-parliamentary group on artificial intelligence. Now, normally this would be a lovely event. It would be on the kind of terrace at the House of Commons with punch and, well, it was miserable. We were trapped in our virtual environments, sharing our festivities, as you will remember, well, certainly those of us who obeyed the law at the time, sharing our festivities in the joy of our own rooms using Teams or whatever virtual platform we had. I put together a presentation, and in the spirit of a Christmas lecture, I sort of imagined a Christmas carol for AI, and I started off with that great Dickensian novel. There's that wonderful start, Marley was dead to begin with. There was no doubt whatever about that. And on it goes, unfolding into two glorious initial paragraphs. Dead as a doornail. Then he goes on to segue into, is there anything particularly dead about a doornail? I might have been inclined myself to regard a coffin nail as the deadest piece of ironmongery in the trade. Brilliant, brilliant introduction to a novel. I'd actually gotten hold of the current best generative tool that I could find. It was actually a derivative, a relatively small Megatron model, about 11 billion parameters from Facebook at the time, that you could find on the web. And I'd given it a paragraph, the first opening paragraph, and asked it to extemporize the next paragraph. And here we got before us, back in 2020, seems an age ago, the completion that the generative tool gave us. It really wasn't bad. He had no "I'm sorry for you" to be heard when he died. He had no forehead to be furrowed when he lay in his coffin, no eyes to shed tears for him. He had no lips to speak words of grave significance. He had no body to be reduced to ashes or blood to be spilt upon the ground for him. There he was, dead as a doornail. Marley was as dead as a doornail. Now, I kind of expected that to just blow the kind of all-parliamentary group away. And there's kind of just and I think it had not burst onto the scene in quite the way it did with subsequent exposure to things like ChatGPT. But to me, it illustrated an extraordinary accomplishment that already, with relatively early versions of these generative tools, we had a piece of fiction generated that was compelling, that read well. I thought this was a moment where I would have to reassess where the trajectory of AI was going. So fast forward another 12 months, and I was asked to write an introductory chapter to a collection that James Manica was putting together, the Daedalus collection, online, the Journal of the American Academy of Arts and Sciences, open source, all those essays are there. And in it, I wrote the introductory chapter, and I take a line from Darwin's great book, "From so simple a beginning, endless forms most wonderful continue to evolve." Okay. So the idea was to track the history of AI and understand how it was evolving and how it's beginning to speciate, to fill all sorts of different positions in the niches of the digital world. So actually, as an afterword for that book, James Manica had actually gotten hold of the most powerful generative AI system at the time. And he'd had a little bit of a discussion with the head of one of the great Oxford colleges, John Vickers. And there's famously a set of exams you take if you try to get one of the fellowships at All Souls. It's a set of questions which students have to sit down and answer in as imaginative a way as they could. And these were the kinds of questions. Some of them you might think of a bash at, Turing test. Oh, we might all fancy a crack at that. How has the representation in literature of any of the following changed over time? Discuss with reference to an author or authors of your choosing, from anthologies to bathos to yesteryear to zine. That's a tough question. Okay. Those questions were meant in some sense to challenge the capability of bright young minds to get into one of the great colleges of Oxbridge. And the truth is, the system did remarkably well. In fact, it blew away the people who looked at the results. And of course, the rest, as they say, is kind of history. With the release of GPT, we can all dish out those questions. What is Kant's view of judgment? Out comes a relatively well-considered, informed response. Or write me some code. Classic early AI problem in a classic early AI language, Prolog. Out comes the code. So we sit there in possession of these tools, and it's easy to imagine, I think, in the extraordinary enthusiasm, that's where AI is. That's AI. So my first fact and fiction is just to remind us that, in fact, AI... What has happened to that? Oh, it was all going so well, sort of. Let me just... Gosh. Well, there's clearly some debugging to do there. Is it the connection, or what is it? Is it back? Okay. The indeterminacy of computing, you see. It's a collection of techniques and methods. And it's important to remember that, because whilst there is a huge set of methods around machine learning, the techniques of logic, of classic knowledge representation, of knowledge-based systems, of search, have their role, as we will see. It's not as if there was no progress in AI. It was just not as if there was no machine learning before the transformer architecture back in 2017. It's important to remember that fact, because we need to modulate, I suspect, going forward, many of the features of generative AI with other methods from our tool set. And I'll come on to that a little later. So, important fact to remember. Of course, the story of our generative transformer architectures is extensive, and many of you will be aware of this. You can go back variously, at least to Word to Vec in 2013, when for the first time people were beginning to think, what if we represented words as an embedding in a essentially re-representation of tokens? And that re-representation is a very, very high-dimensional space where similarity to other words, word embedding, or wider context can be represented. And that idea has bloomed and blossomed into many variants and versions. Until now, we are possessed of transformer architectures where one of the overriding principles is extended attention or memorization. Huge amounts of capability to encode not just the local word, but huge extended context, to capture the long-range dependencies that might exist when we use words, such that when we reproduce the next most likely token, it has this extraordinary ability to be coherent, to be reasonable, to sometimes be right. Okay, but we'll come on to that. And with OpenAI, their GPT-3 architecture really did transform the stakes. How many in the room? No, we probably shouldn't ask who's got a subscription to GPT. That's a bit naff. And we'll just carry on. Okay. So, recurrent features. I want to talk a little bit in the time I have left about some of the recurrent features of what we're seeing in this landscape, which is evolving all the time. Because, I mean, as you look at the speciation tree, if you will, the ancestor tree of all of these systems, even recently, there is much variation going on. I want to talk about scaling properties, a little bit about engineering. This sounds like it might be an hour-long keynote, doesn't it, Cassidy? You'd be very worried at this point. But no, I'm just going to glide over these very quickly. Something around capabilities, benchmarking, something about data, and then remind us all of the deep issues about risk management and alignment. So we will recall that when the Palm paper was released, this was the first indication that something remarkable might be happening with these architectures, which is that as they scaled, they seemed to get increasingly competent at the tasks we would give them. And that scaling, of course, required huge compute. It also required huge amounts of data. And the original Palm paper is interesting because it, for the first time, revealed that half the content being ingested was social platforms, social media, conversations. No wonder there was a huge need to detoxify. No wonder there was a huge need to do all sorts of various cleanup. Large amount of filtered web pages, multilingual books, GitHub code, of course, Wikipedia. Wikipedia, 4% of the original corpus. What is interesting as we begin to revisit these systems is how the quality of the data can actually allow you to produce much smaller models that are, in many respects, sufficient to the needs that users might have. Well, keeps happening. GPT-4 then comes out. GPT-4 comes out with an extraordinary claim to 1 trillion parameters. Hard to know exactly, because what had previously been rather fully disclosed, as the commercial imperatives arose, got greater, there became an absolute, almost an arms race in this space about what could and couldn't be said. But what was declared was just the benchmarking again, just how effective GPT-4 seemed to be. And it suggested to many people that this scaling function was fundamental. In fact, the great worry was that since your model size, you typically needed about twice as much data as the model size, we'd run out of data. And there's much discussion around what happens in that context, where you get it from. Interestingly, if we look at Google's largest models, Palm 2, the latest versions seem to have reduced very substantially the underlying parameterized model. About 340 billion, not 1 trillion, for example. I have to say that when you look at the capabilities of this system, it is truly impressive. One of the great AI hard problems was language translation. Just looking at Palm 2, its ability to move between languages, to move into languages that are relatively underrepresented on the web, and with the deep models that have been statistically aggregated in the languages that are seen, it can make extraordinarily decent translations into other languages. Even to the level of this lovely example here in the Palm 2 paper, which is actually giving you examples of proverbs from one language to another in the actual original script, grammatically well-formed, or meaningful analogs to those. Impressive. And on the standard benchmarks, impressive results again. Now, there is, interestingly, I think, a recognition that whilst this is all well and good, we don't all have access to 3,000 tensor processing units or some huge number of NVIDIA processing units. And so there's been a lot of attention just recently on how we might make these models smaller and still have a lot of the benefits. And I think this is where we're going to see a huge amount of work. No doubt the great models will continue to evolve and develop, but for just pure issues of sustainability, energetics, come on to a comment on that, we're going to need to be more thoughtful. Many of us would like to run these models on the kind of laptops and machinery we have available in our organizations and research institutions. So Bruce Schneier has quite an interesting blog on this recently, where he's arguing for the value of open source large language models, not least because we can then interrogate them, use them, understand their strengths and weaknesses, experiment on them. And other people are recognizing that as you distill the large models down, as you reinforce them with human feedback, you can carve out a much smaller, effective model for subsequent reuse. Now, just a moment on the engineering. Of course, we've all seen Moore's Law, but it just gets crazy. As you start to move out to where we are with things like the NVIDIA's A100 or A300 even chips, that rise and rise of that exponential. People say it's always about to run out, except that we come up with ingenious new ways of arranging compute infrastructure to keep on giving us remarkable compute. But what we don't always recognize, so this is another fact as opposed to what people might imagine, is the extraordinary ingenuity that has gone on to build those biggest language models, the engineering behind, the ability to keep 3,000 processors up and running simultaneously is a significant engineering challenge. One of the interesting things we've noticed is that this class of system actually requires particular sorts of compute. And what we're seeing there, of course, is hardware that is designed to support that kind of compute. One interesting feature is that at train time, they don't need to be very high precision. That is, you don't need the 64 bits of your standard general processing unit. You can get away with much fewer. So Google's tensor processing unit actually had taken that on board, and less precision, less size, more transistors on the chip. Or building in explicit support for the matrix multiplications, the particular kinds of arithmetic that needs to happen inside. So you specialize that in silicon. That has been one of the, I think, unsung aspects of much of the work in large language models. A word on benchmarking. The ability to assess how good these models are has become an industry in itself. Hugely important that we have robust ways of making evaluations. And as you do that, you start to see attention given to other aspects of performance. One that I particularly like is the work that was published by Banguly et al., which recently published this year, which is showing how with human reinforcement learning through human feedback, RLHF, you can actually self-correct models to have them exhibit the kinds of outputs that you think are desirable in terms of the values you aspire to, the values you're engineering into this. So they can learn to be less biased, not to be susceptible to stereotyping of various sorts, to follow instructions to avoid certain kinds of morally harmful output. And I think that when we imagine building these systems, we have to pay a huge amount of attention to the fact that the process of shaping these systems is, to some extent, still an art and not a science. I'll come back to that. They show remarkable capabilities. The theory of mind, for example, the idea that a model might have an ability to answer questions about your view about my view of the world, in which things might be manipulated or changed. A standard test, I should say, in psychology for all sorts of conditions ranging from autism. Can you appreciate a change in the world and appreciate that my view of the world might be different from yours, so we don't share the same model? Again, tests on this are revealing that these models have at least a first pass ability. Now, theory of mind immediately suggests they've got a mind. Just to avoidance of doubt, I'm not in that camp at all. These extraordinary constructs are smart in ways that aren't smart like us. And in a way, we've got to put much more work into understanding that basis. Common sense reasoning. Nice example here, the work of Yulin Choi. Her work has showed how these models can actually capture large amounts of what we think of as common sense reasoning, the stuff we take for granted, the fact that water flows unaided through gravity. In fact, any liquid will. Gravity flow. You don't need to move things from one place to another via a pump if you've got gravity flow. How's that common sense knowledge of engineering built into everything we understand about the world? Well, it turns out there's going to be a role for other forms of AI where you represent the dependencies between those sorts of facts as underlying theories about how the world works. So blending these symbolic methods, these graph-based methods, with sub-symbolic methods, the kind of encodings we get in our large language models, is going to be an active area of research. The need to link these models with what we sometimes call good old-fashioned AI. Now, there's a lot of work on how you break these models, and I haven't spent a long time delving into that, don't have the time to, but be aware that we still, and the people who work in everything from the security services to enterprise computing realize prompt injection to get various information out of large language models is problematic. The problem around data leakage, the fact you can shape these systems to actually endorse hate speech. So all the stuff I was telling you about shaping a large language model to align its values in a positive way, you can simply build the best toxification agent in the world, or the best troll farm you can imagine. So there is a huge need for us to think critically about the limits and fallibilities of these models. And there is a huge need for us to understand how these models work. The engineering is far in advance of the science. So we understand something about their behavior. We understand something about how to stand these models up. And we're still looking for ways to describe and have these systems account for their behavior. And perhaps a final comment on fact and fiction is what happens when you get this entanglement, and I'm sure we'll be talking about it over the weekend, around human-generated content and machine-generated content. This was famously a photograph that won a prize, and it was announced that the prize, this was for human photographers. This was actually a synthetically generated image. Now, it's not as if we don't have any agency here. So people often say, well, one of the features of these large language models is they've hoovered up all this content off the web. Have they done it in violation of copyright, IP? Well, that's just something we're going to have to get over. The age of these smart machines is present, and they are so powerful that ... Well, witness what's been happening just recently. The Screenwriters Guild of America went on strike. It's actually come to a settlement. There are litigations underway or action suits underway right now where artists, creatives of various sorts are getting together and deciding that they will not have their content hoovered up arbitrarily as they see it and then reproduced in a way that is violating their IP. You may remember some back to music peer-to-peer sharing systems, Napster. A technology that seemed to offer a huge amount, had established itself, was offering services, literally halted in the face of legitimate claims, as courts judged, from IP content generators, from the artists themselves, from the musicians themselves, from the companies who hold this. Now, we can argue about the settlement around IP, but it is not as if this couldn't become hugely consequential, and it will also argue, again, for the need to think carefully about data and data architecture, what is being used. A recent paper by Microsoft, it was a nice riff on the original Transformer paper title, Attention is All You Need. This paper was called Textbooks Are All You Need. And what it showed was that you could build a much leaner, smaller language model if you gave the system exclusively high-quality textbook information to absorb and learn from. There's going to be a question about the data we use and choose to use, how we incorporate it, how we qualify it. So the space of data architectures for AI will be a fundamentally important one. And the final point I want to close on is, in all of this, we need to remember that when we build these systems, we have to understand how they align, how they embed within the context in which we want to use them. Just literally 2 nights ago, Alondra Nelson was in this room talking about the importance of what she called thick alignment, arguing that when the companies talk about alignment of systems with human values, it's a very techno, thin characterization. A proper alignment takes into account the whole range of human interests and perspectives to understand how they embed themselves into our lives, into our workplace, into our relationships with one another. And that brings us back, irreducibly, as it always does, to the issue of the ethics, the governance, and the regulation. It will not have escaped your notice that there is going to be a summit where the UK is bringing together many stakeholders and associated events around that to try and work these issues through. Extraordinary thing, after 40 years in this field, I've seen highs and lows, summers of winters of AI. What's extraordinary about this manifestation is the extent to which everybody is interested in what these systems might deliver and how they might deliver it. AI, with those methods, has been changing the world for decades. It's going to continue to change the world. And doubtless, there will be, at the very moment of maximum interest, there'll be people understanding where these systems need to be qualified, where they might have frailties, where they need to be embedded thoughtfully, where we can do innovative new things with them we hadn't thought of, and where their architectures might be supplemented, changed, augmented, reduced. That is an exciting world, a world that you and others will help to bring about. I'm fascinated to follow the discussions. Thank you very much.